Now, in order to really describe why we have visualisation at the Royal Opera House, I need to explain to you a bit about the Royal Opera House itself. It's not your typical theatre. And in particular, I'm going to go through explaining the tight schedule that we have and the scale of the business, and it'll help you understand why we have to have this facility. So the first thing you've got to know about the Royal Opera House is it's big. I mean, really big. It's such a massive industry. We call it a factory inside because we're just churning out ballets and operas. It's just a non-stopping process. We produce nearly 30 to 50 new shows in our main house every year. That doesn't count our secondary and tertiary spaces, 10 of which are new productions. They're all full-scale West End style sets. We put nearly 1 million bums on seats every year in our main auditorium. And we have 300 shows in our repertory system. So 300 shows that we have that we can pull out any time and put on our main stage. It was originally built in 1732 by John Rich at the proceeds of the Beggar's Opera. And in the 280 years since, there's been 3 different theatres sitting on its site. The most recent incarnation was built in 1858, and all the others have been burnt down. So we've been very careful with our fire and safety standards since. It stood there for about 150 years until 1999, where we had a £178 million refit. And the end result of this was the most advanced technological theatre of its time. We're now a £100 million a year charity. We do live cinema feeds, big screen outdoor events in Trafalgar Square in Liverpool. We do DVD sales, radio broadcasts, we have studio theatres. We go on tour all over the world. We have corporate events like the Olivier's, the BAFTAs, Elton John's private performances. We've been to Buckingham Palace, we've taken shows all over the world. It's a massive produce of productions. We also do a lot of work with education. We have schools performances, we have educational projects, we have work experience programmes and apprentice programmes which we've recently adopted. In addition to our main site in Covent Garden, which is in itself one of the largest footprints of business space in London, we have 2 additional facilities, or actually even larger. One up in Wales, where we store our 300 shows in 3,000 freight pallets. Also, we have a new workshop in Thurrock, which has just been finished last year, which was built to build all our scenery. We had a previous facility we moved into. And this is a new energy-efficient building with a lot of community integration and education work. We have a whole education department there working with local schools, teaching them theatrecraft. So, we're really spending our Arts Council funding well, making sure that every single penny goes back into the industry. When you start to consider the scale of our business and all the staff that we've 1,000 permanent staff, 1,500 freelancers, you start to see why our top price tickets for operas can cost £250 each. Now, the refit that we had in 1999 left a lot of new facilities that we've used well. We have 2 new rehearsal rooms shown in red. Each rehearsal room we can build a full-size set in there so that the cast can rehearse in full scale. We have a build area where there's an articulated lorry lift. We can bring an entire lorry in, bring it up to stage level, and build our sets off the stage to keep the stage free for productions and rehearsals. Now, the way this is all connected together is through these pattern of grids. These are actually wagons on the floor. The entire floor moves like a massive Tetris game. So you can build something in the build area and wheel it into your rehearsal room to rehearse with, and then wheel it across here into stage. Now, what this has done to our productions is it's meant that our turnaround time has changed from being hours into minutes. From days into hours, and we can get the stage the set onto our stage in just a matter of minutes. So this has meant that timings have become even tighter, and the longest part of our change-around process between productions is actually the lighting, because the lighting is the one thing that we can't move in. It's already there. It's part of a standard rig. So this is where visualisation starts to come into play. So this is a typical schedule of our day. It's very, very quick. The most important thing is that we have 2 completely different sets on stage in a day. So we start off in the morning, the crew come in and they build a set, full scale, all lights focused up, exactly as it would be for performance, in a matter of about 3 or 4 hours. We then do a rehearsal that lasts about 3 hours, and that's all the lighting designer gets, by the way, 3 hours to do a rehearsal, maybe 4 or 5 times in a week, 10 times if it's a new show. And then it's all stripped right back to nothing in a matter of about half an hour, and then the whole new show put in for the afternoon, ready for the evening's performance. It's an incredibly tight schedule, and a lot of hard work goes on to make it happen. But what it means is that if you need anything else at the stage, you haven't got it. You have to have a second facility. You almost want a second Royal Opera House that you can work in when you haven't got it. well, that's where visualisation comes in. We built a second Royal Opera House that they can use whenever they want, but it's just not the real thing. But I'll explain to you later how we managed to make it work almost the same. Now, the lighting rig itself has almost 800 lights in its permanent setup, with an additional 200 lights available if somebody wants them, as a designer wants them on stage. Everything overhead is automated. Every light that can't be reached by a person on by walking or over a ladder is automated. So that means that everything overhead is a custom generic fixture. So it's like a source 4 and an auto yoke, or a 2.5 kilowatt PC and an auto yoke with a handful of moving lights. We have 50 electricians employed at the Royal Opera House in the lighting department who work in teams or shifts to be able to help produce the lighting and our quick turnaround. The stage lighting positions themselves are movable, so that's our batten there, where our lights are positioned. Now, all of these can come in and out to millimetre precision, and they're controlled by our automated flying system, the Nomad. It's a stage technology system. Where we're walking along at the moment is what we call the rise and falls. These can go up and down as low as 2 metres and up as high as 12 metres. So all the battens are automated. Our proscenium arch, which has a perch positions down the side with loads of lights and a bridge, which can fly in and out. They can all fly up and down, as you're seeing there at the moment. They can fly up and down stage. The perch can go in and out. They're completely movable, so we have complete flexibility of where we want our lighting positions to be. The actual fly tower is triple hung. We have 150 fly bars, and the fly tower is 35 metres high. So we can hang one set and another set above that. So we've got space for 2 productions to be hung at one time. Our control infrastructure is the ETC EOS, which we recently bought 2 years ago. It's all built on a fibre optic network. And every EOS station has a visualiser, so that anybody working on EOS can have access to a visualisation system. Now, control teams start working with visualisers very early on, whether it's a revival or a new show, to start preparing their show files, getting information ready, pulling all the archive back, making sure it came back correctly. Now, as I said, 2 years ago, we upgraded to the EOS from the ETC Obsession, which is a very different lighting console. So we have to make sure that all our show files are pulled back accurately and that no information has been lost in the conversion process. And that's something we would love to do on stage, but don't get the time. So that's where our second Royal Opera House, the visualiser, comes in. We get it all set up on there, and we can have a look at them side by side. The lighting visualiser itself, well, we base this in what we call a vision suite because we principally use ESP Vision software. The Vision Suite is up in the depths of the building, and we have a space there for a designer to sit with an EOS to control it. Lots of very big computers and a projector so they can see it on large scale. And the designer will sit up there and work with the programmer, the lighting managers. Sometimes the designers and directors get involved as well. And we create the lighting up there before we get to stage. The model itself is complete in its entirety. It has every single lighting fixture in it, whether it's generic or automated. And the software allows us to pan around, have a look at different angles that you can't see in real life. You can turn things on and off. You can add gobos, change colours. You can add setting really quickly. It's a much quicker process for a designer to work in. If they're trying to be creative, if they're saying, oh, can I see that border on the bar upstage? It's just 2 types to change it. Whereas in real life, you have to bring the bar in and move it to a different bar. It could take 20 minutes. So for designers to be creative, it's actually a very fluid process. You can work with it quite nicely. Now, the software that I just showed you is ESP Vision, but we also use a host of other software, including WYSIWYG, which most people are probably more familiar with. But we also use a lot of software from the animation film industry, like 3D Studio Max and Autodesk Maya. And these programs are actually needed to get the models ready to go into Vision, but they also have added benefits themselves. You can create animations, you can do renderings, you can do a lot of lux studies as well, so do your light levels. So we have a whole load of software that can aid visualization and not necessarily just ESP Vision. A lot of people ask me when I'm building these models, some of them can look quite complicated, so how do you go about behooding a model like that? Well, the answer I always give them is I start at the bottom and work my way up. And just to demonstrate that, this is how I see it. It starts. So maybe thousands of pieces of modelling, but they're all very individual, and I can build them up one at a time. And before you know it, you've got a complete model built. So it looks complicated when you see the finished product, but when you look at each individual piece, it's actually quite simple. The finished result comes together in the visualizer, and we've done about 80 shows since I've joined 3 years ago, where we've produced 3D models of our sets. And all the values in the lighting desk represent what's happening on stage. So the set's to scale, it's millimetre perfect, it's in the right positions, all the lights are in the same relative positions as they would be on stage. And when we focus a light up, we know that in principle it should transfer to the stage exactly the same way, with a bit of an error margin, I have to admit. So we focus the lights up in the visualizer and save it on our EOS upstairs. We put it on a memory stick, take it downstairs, plug it in, and the light's pretty much where we left it. So it's got a lot of options. We try to improve on the accuracy of this by calibrating the lighting fixtures in the simulation, because as you probably know, no light comes out of the factory perfect, and no one is the same as another, especially when you've got a custom lighting rig like ours with lots of alter yokes. So we actually go to stage and compare what we see in the simulation to what's happening in real life. We make the simulation match the real life version. So if the pan needs to tweak slightly or the zoom needs to go in a little bit wider, because every light's unique, and when you've got a permanent rig like we have, you have got the option to try to tidy that accuracy up. Hopefully in the future we'll have some RDM technology or some sort of feedback system that will do this process automatically, but as far as I know from the software manufacturers, we're the only people that are actually doing calibration at the moment. I'd like to talk a bit now about visualization as a concept, because I think it's quite an old concept. In fact, probably as soon as cavemen started drawing on the walls how they're going to kill the beast, that's a visualization, because they're explaining how they're going to do something. Every day we think and imagine things that we have to turn into practical mediums to describe to other people, whether it be sketching out, back of a fag pack sketch like a whiteboard sketch, or we do our 2D plans in the theatre because it's a good way of explaining how our lighting design is going to look in symbols. It's a way of transferring to the crew how you're going to build something. That's all visualization. Obviously, architecture and engineering have taken this a step further with their sort of 3D models, because for them, as I said at the beginning, architecture require a medium that they can all collaborate with to help make the buildings more efficient, make them more effective on site so they're built accurately, and for engineers to make sure that the physics of their ideas will work. So these ideas have been happening for about 10, 20 years for those two industries. I always think that visualization is about interpreting our sort of cognitive thought process into a practical medium. So if you think of anything that you have to do where you have to sketch something out or model it or get a piece of paper and fold it to describe an idea, that's a visualization. So that's enough philosophy. This is another visualization. Before I came across visualizers, and I've got to admit I was about 14 when I first discovered WYSIWYG and got very excited about it. I used to do spreadsheets like this when I was lighting a show. I'd produce a list of all the channels and a list of all the cues, and write in between what channel, what intensity I wanted to be at, or what colour I wanted to be at. And that was a form of visualization. I could then give that to the board op and they'd create the show file, and it would all start to come together from that. Now, we have 3D visualizations. I don't need this anymore. Not everyone's so lucky to be able to have the software at disposal. But that is a form of visualization as well. So what's important to remember about this is that 3D modeling is just another tool. It's just another form of visualization. It won't replace anything we have already. We can still do our spreadsheets. We can still do all our back of the fag packet sketches before we go into a venue. But visualization is just another way of working. The theatre's been quite slow at adopting all this, especially compared to architecture and engineering. But I believe that if we do start to adopt it, we can really move our industry forward by tenfold. So who actually uses visualization in the theatre at the moment? Well, I know we do at the Opera House, but who else does? Well, certainly a lighting designer would. You'd always expect to see a lighting designer using a visualizer, and probably the lighting programmer working with them. If it's a big show, maybe the director was sitting on it. Now, for most people, that would probably be the extent of who would sit in a visualization system. But this is actually who I believe uses visualization. Now, this isn't hypothetical. This is completely real. Every single name or title you're seeing here has used this system at the Royal Opera House or has benefited from it. Now, the next part of my presentation, I'm going to go on to explain a whole production process. We'll be quite quick, I promise, and explain how each one of these names will appear on the top right-hand corner of the slide to describe how they benefited from the system. So I'm going to prove to you that every single name here will come up. And I've had a lot of people say to me, box office, how did box office benefit from it? Trust me, wait and see, you'll see it. So let's start at the beginning. The very first part of the production process is the white card meeting, it's the initial designs. And you can bring visualization in straight away for this, because at the moment they build 3D models out of cardboard or clay. I've seen wonderful things made out of polystyrene. But something it doesn't give you is the perspective of seeing a model on your stage, in your auditorium, to get a sense of scale. Now, I love a 3D model box. I don't want to get rid of it. There's something about the materials, the textures. It gives the designer a creative medium that they can actually work with. It's part of their design process. So we're not getting rid of that. But imagine if you added this in. There's lots of things that you could do. For instance, the model room technicians or the CAD workers, they actually got a 3D model they can already refer to build their 2D plans. You could be sitting in a meeting and the designer could start having ideas, and rather than having to go away, make a new model and come back again, you could make changes there and then. You could be sitting in the meeting saying, well, how about this? Let's look at how, that and change it, and they get the idea straight away. Next in the process is looking at sightlines. We do a lot of sightline studies at the Opera House to make sure that our very expensive seats actually look into the correct part of the set. When we went to the O2 with Romeo and Juliet, it was very important that we looked at sightlines because it was a new venue. We had lots of different attributes to consider, such as the lighting trusses, masking, video walls, the MD had to be seen, and the audience had almost a 360-degree view of the stage, and every single person we wanted to have a good view. Well, we produced this model to make sure that we could actually see from all the seats. And this is what we came up with. Now, it looks quite nice there, but when we looked at it in the meeting, we had the entire creative team in my tiny office, looked at it and went, oh dear, we've made a mistake. So we've put a proscenium arch set and built a proscenium arch stage and stuck it in an arena. And it just doesn't work, does it? And we couldn't see it in the model box, we couldn't see it on the CAD plans, we had to see it in the visualizer to understand it. The next time we would have seen it would have been when we got there and we'd built it and we spent all that money and we'd gone, oh no, we've not understood what an arena venue needs to have to be accessible. So we changed all our set around, and it was actually commented on in the press, and the reviews we got was how we managed to make a ballet fit into an arena so nicely. And it was because of this. It was because we actually saw it in the visualizer and made it work. And as an added bonus, we discovered there was an extra 1,000 seats we could sell every night. So in that alone, we already made our money back on the system. So it has lots of extra benefits that you never realise will be there. So going back to the Royal Opera House, I'm going to talk a bit about Tannhauser, which was an opera we did last year. This opera didn't have much set. It had a replica of our proscenium arch built on stage, which flew in and out, and that was pretty much it. But the idea from the director and the designer was that all of our floor elevators, which we have 6 on the floor, sort of sitting like this, were going to go in and out. We had flybars going in and out. We had lots of masking around the outside that's going to be flying in and out. In the first 10 minutes of the Overture, there was going to be 30 flying queues operating 100 different events, whether it be a flybar or an elevator. And you saw our schedule. We got 3 hours, about five days of 3-hour sessions to plot this in. So stage managers came to me and said, we can't do this. The director and the designer's idea is just not going to work. So is there a way we can visualise this? And I went, I don't know, let's try it, see what happens. And we did, and this is what we came up with. Now, this is a sped-up video of the Overture, and you can see just how many events there are happening. And what this gave us a chance to do was to identify any areas with the blocking, to make sure that cars weren't standing under elevators that were about to move or flybars that were going to come in and hit them. It meant that if there was a change, the director or designer could make it there and then. They could go back to the rehearsal room and change the blocking of the cast. We identified areas where there was going to be dancers jumping over gaps in the stage that were 6 metres low, and we just hadn't appreciated it without visualising it first. It also gave a chance for the musical director to come up and talk to the DSM and go for the cueing, go for the nuances of the music, make sure that it was all appreciated in full. And it was a massive success. We transferred the information manually to the Nomad flying system and went into the first technical rehearsal and ran it with all the cast knowing exactly what they were looking at because they'd seen videos of this. They all had a very clear idea of how it was going to work. And it was like we'd done it 5 times, not 1 time. It worked very well. And this was even before the lighting designer got to use it. Now we're going to talk about the video program. Now this is a very bad quality filming, but what I'm describing here is Misfortune, which is an opera we had in the other week. and this here is a sail, which weighs about 100 kilos, and it spins around the stage in every which axis you can imagine. It rotated, it spun, it flew, and they projected a media server image onto this sail. Now, it's not unusual to mask around something on a stage, but it's a bit unusual to have it moving with pieces of set as it goes around. And we weren't sure if we could do this, so about a year and a half ago, before the production came to us, the production manager came to me, and in a very similar way to Tannhauser, said, I don't know if we can do this. Should we visualise it to have a look? So again, we went, don't know, let's try it, let's see what happens. And we put the media server image into the visualiser and created the mask and tried to see if we could get our media server to map around the moving objects. If I play it for you, you can sort of see how it works. As the sail moves, the mapping of the projection moves with it. And it gave them the confidence to go forward with the idea, to invest in the projects. It also gave them the idea how to actually program it. It took a long time for our video engineer to work out what the best way to actually program something like this in. If it needed 100 different points to follow it, or 6. Do you need another software to manage to track the sail? So it gave us a lot of confidence in the idea. Right. We do a lot of filming at the Royal Opera House, but because we do a lot, we know exactly where to put our cameras in the auditorium. But when we went to the O2, we weren't really too sure. It could have been anything. So we actually used a visualizer, which was as good as being there for real, to put in camera positions with lens types, so we can actually see how it's going to look. So we could sit there with the video engineers and say, well, do you want a 10-degree lens here? Or, I don't really understand cameras, but they decided what lens type they wanted and where they wanted them, and we were able to block out the seats that are relevant. And again, save money because we found more seats that we could sell as a result. So that was a great use of the system that we hadn't expected to understand. So moving on to lighting, that's probably what most of you are here. You don't usually expect to have to do a pre-focus in visualization for generic lighting, because ultimately you're going to have to do it again when you get to stage. But there are some good reasons for doing it, just because you can't transfer it on a memory stick like you can with moving lights. First of all, it gives the lighting designer a chance to try out their ideas, sort of practice the focus, make sure that what they want to achieve is possible. It also gives them a chance to develop their language. We have a lot of international designers at the Opera House, and it's funny how many different words they use for something that we consider quite common. We even get people that don't understand stage left, stage right. They work on left and right. So actually sitting there with the crew and going for the focus with them helps them understand that language barrier. We can also use this system to make images for the crew to work with, so they can understand when they get to stage. They've got a picture and they can actually focus it up to that. So that's a time-saving technique as well. It also gives the production managers a chance to ascertain costs early on, because you might realise you need more lights or less lights. A great example of that is when we produced fairies in our studio space, the Limbury. Now, this was an almost entirely generic lighting rig, with the exception of a few moving lights. And we tried to focus every single light up before we started plotting. And in the process, ended up rehanging virtually every single light. Because she realised that she could, we easily moved things around on the bars to get the perfect angle, which then meant that the plan was updated and it was all rigged in the right place. Now, when she got to stage, she would never have done that. It would have been a waste of time. But by moving the lights around, she had a much better looking lighting rig, and the design was much better as a result. And it was made even better by the fact that we discovered that the beam angles she specified were too narrow. So about 50 lights need to be respecified from the hire company to a wider beam angle. And again, once it's rigged and you discover that, it's too late. What do? The design suffers. I mean, you could spend the time. If you had the time, you could take it all down, go back to the hire company. But that's a waste of money as well. So it's still a good idea to do some work, preparatory work in the visualizer, just to help cement your ideas down. Now, automated lighting is really where pre-visualization started. It's where WYSIWYG first started making its money. It's where the Opera House started using it. It's all about putting your light on the stage and then transferring it to a lighting desk and not having to do it again. Now, we try to tell designers that there's a 10% error margin with their moving lights. You can pretty much point it in the right direction. You can move some shutters in, but you have to do some work on it when you get there, because it's not going to replace your focus time. And I'm going to stress that a few times because it's a misconception. You'll have to go in there and redo what you've done already in the visualizer, but it'll take you 1/10 of the amount of time. Now, every designer is different. They all have different ways of working. We try to accommodate that. whether it be the position of the camera that they look on the stage, or having measuring grids that they can work with to plan out their lighting. We actually got the facility up there to produce anything we want to. There's no laws of physics, there's no laws of nature, so we can do anything we want to give them the freedom of flexibility to create their ideas. And then it's our job as technicians to bring them back down to earth or to make it happen. You may have seen on Sunday night we had the Olivier Awards in at the Opera House, and I couldn't resist putting a couple of pictures in because it was just such an exciting event. But this was very exciting for me, to put so many lights into our venue, to have a complete model of auditorium and see such an amazing lighting rig take place. Now, the lighting programmers for this used the Grand May, but didn't use our EOS, but he programmed 1,800 lighting cues in up here. Now, you'll hear this story a couple of times. It does happen quite frequently in our industry. But there was a delay on stage. I'm not going to say why. But the delay on stage meant that we didn't have any time to plot when we got to stage. He had enough time to update his focus groups. But the entire Olivier Awards, which was filmed live on Sunday night, was done based on the visualisation. And it was pretty damn good. You couldn't tell that it wasn't plotted at all. Now, if he hadn't had access to this system, I don't know what he would have done. There wouldn't have been a way of producing lighting for that show. It would have been something very basic, I'm sure. When John B. Reid went to the O2, he had a very clear idea of how he was going to focus up his lighting. He worked in what he called systems, lots of layers of light. There's a way of managing a big lighting rig into small systems. Some designers are much less clear. They don't really know what they want to do. They come in and use it as a very fluid working system, so they'll start being creative and try ideas out. And some just come in and just bash it out, and they know exactly what they want, and they work exactly the same as they would on stage. So it's quite interesting as a visualizer to experience different designers' working styles and how they come across the system, how they actually engage with it, because it helps inform us how we should improve it in the future. Now, as I said before, pre-visualization isn't perfect, but it will speed up your work. You can do a lot of work before you get into a venue. Now, shutters in particular are quite bad at coming back, and we've got some VL1000s which are notorious in the building for, we do the work in the visualizer and we come back and it's not looking exactly anything like it did in the first place. But we try to encourage designers still to do the work accurately because it gives them a chance to see how it's going to look. It gives the programmer a chance to practice the way the design's going to go, so they can go back and accurately recreate it on stage. You can create pictures to use. You can do lots of things that still make it worthwhile. We also do a lot of lighting effects up there. Sometimes you can spend a long time doing effects on stage, which you have the director breathing over you, you have the cast waiting on stage, and this particular effect took about half an hour to program up for a production of Fairies. But it's much better to do this in a relaxed environment, in a visualised environment, because you're still going to have to do some work when we get to stage. But if you've saved half an hour of your production team's time, they're going to thank you for it. Now, you've got your focus palettes built, you've got your effects, you've got your sets, you've got all your information built in little groups. Now it's time to put it together into your cues. Now, when John created the O2, he bashed all this out in about a day. He had all his focus groups already built carefully, and he knew exactly what he wanted to produce, but he kept it simple. He didn't go over the top. We have a lot of designers that come in and try to put every single generic light in, and they try to guess a value for it. And when they get to stage, they can't tell the wood for the trees. It's just so busy. So John B. Reid had the right idea with this one. He kept it very simple, using layers. And he had a right estimation of how far you go with a visualizer. You shouldn't do too much. You should just pull back a bit and do the work you know is going to benefit you. It also gives a chance for the lighting designer to work with the programmer and develop that relationship. Again, I said with focusing lights, it's very important having that relationship and that communication. It really paid off for the O2 because, very similar to the Olivier Awards, we lost about 8 hours of our plotting time, which was the plotting time. So we ended up going to the first rehearsal with nothing but the visualised show. And again, it worked very well. You could then plot over the rehearsal rather than having to start from scratch. Dancers don't like it when you plunge them into a blackout because there's no cue next. So again, it was very beneficial to them as well. This is the finished product. Okay, but this isn't the visualization. People got confused last time I did this. They thought this was the visualization. I went, wow, that's good. This is a real picture, in case you couldn't see it. What I'm going to show you now is a visualization. So it's not the same. You can see straight away it doesn't look the same. It's not photorealistic, but it looks pretty good, and it gives you a good idea of what the lights are doing. It's a representation, and that's what I'm really trying to get across here in this presentation, is that you can use this for itself, but you'll still need to go to the stage and do all the work again. But it will take you infinitely less time. You can quite clearly see that that's a beam of light, and it's finishing there. Now, if we look at the one before, you can see where it is. It's soft-edged, it's going over the seats, it's got shadows, but they're kind of the same position, so you know that you're looking at the same thing. It's just that you couldn't design a show off it, it's just that the position's correct. We'll also sometimes use visualization technology to create animations. Now, I built this one for an Amdram show, where we're trying to describe to the director an idea for Judas's death in Jesus Christ Superstar. And also the cast member in particular was very nervous about the idea of being hung. So we created a video to try to describe how this process is going to work. We could convince the health and safety people at the venue that it was going to be safe. We convinced the director and the cast member that it was going to be safe. So there's lots of other things you can do. It doesn't have to be a tool to pre-focus or to pre-visualize flying. It could actually be used just to demonstrate ideas. So now we've got to the stage. That's it for visualization, isn't it? We don't need it anymore. We've done all our pre-focusing. Well, you're wrong. We've got loads of uses for visualization once we're on stage. You'll actually see that at the O2 here. There's our EOS and there's the visualizer running at the same time as the whole rig's running. We believe in this so strongly that we actually have the visualizer permanently set up in our box at the Royal Opera House, and it's always used. And there's 6 good reasons for this, which I'll list out to you. First of all, it gives you an alternative patch that you can rig up. So in this case, Joe, our programmer, was looking at the stage and realised there was lights on in the visualizer that weren't on the stage. So there's an obvious error, there's something not working. So it's something that can be fixed. Also, when you're very far away from the stage, you can't necessarily see what you're doing. So the visualizer is like a window into the stage. Let your lighting designer get close up and do the detail, and then you've got the general view. Also, if you've got a lot of set or cloths in the way or people standing around, you can't see what you're doing. So you can use the visualizer to spin you around and have a look at something with a bit more detail. Now, on our stage at the Opera House, we have a lot of Lick Technic auto yokes, which are a wonderful piece of kit, but they're very, very slow. And you'll find you'll be aiming your light, you'll pan it round, and it'll go around to here, and you'll be like, no, I want to be over there, and you spin it round, and you're doing this, trying to find the middle point. It takes ages. So we sped up this process in the visualizer, so you can look at the visualizer and put it there, and then let the light find it. So it's those little things that just saves a bit of grey hair for the programmers and makes their life a bit more pleasant. Also, save you having to power up the lighting rig if you just need to check one single light. And also, if you've got to bring a bar in or something to fix a fixture that's broken, you've got the option of using the visualizer. So the lighting designer can just jump back with you, just do some work on the visualizer while they're fiddling around fixing a light or something, so you don't have to stop your workflow. Now, finally, there's one more thing which you can do after the show, is archiving your information. And obviously, this is very relevant to people like us at the Opera House, to make sure that what we produce is archived for the next time. So we use, this is actually a WYSIWYG image, but sometimes we use Vision in 3D to create looks of the lighting on the set and put channel numbers against it, so that in 10 years' time, when we pull it back, we know exactly where the focus is. Because the show file will give you values, you know your intensity, you know your colour, you know your pan and tilt values, but you don't actually know where the light is on the stage. So we use that for doing that. You can merge this with sort of databasing software like Rob Halliday's Focus Track or Andy Voller's MLA, which is coming out later this year, to sort of archive information visually, and then you can create a database like this. You can then interrogate it later on. So you can go in, choose a channel, you see the picture of all the cues that channel's in and where it should be pointing. You go, oh, look, I only need one light to do that rather than 5. So this is the future here. So going on to the future visualization. It's time for my crystal ball. So I'm going to predict you now what's going to happen in the future. Well, first thing, the most obvious thing is graphics. This is one of my little friends up here. Graphics is an obvious improvement that we can make to visualization. Now, if we look at the animated film industry, we can sort of get a comparison of where we are, because we're using the same technology. It's the same render engines, it's the same software underneath. So if you look at the film industry, you can see where we should be. And when did this guy come out? It's just Toy Story 1, wasn't it? Like a little short film, and that was about 1990s. So about 20 years ago almost now. And this was one of the very early on animations. And it's actually still better than what we're producing in our visualizers and lighting. But this is something we can aspire to. Now, I reckon that we're probably about 20 years behind. We're almost at this sort of level. But if you look at sort of the modern film industry at the moment, the wonderful work they're producing, this is something we can aspire to. There's no reason why our visualizations can't be as imaginative and detailed as these films are, because we're using the same software. Ultimately, better graphics will mean more realistic renderings, and the more realistic it is, the more lighting designers will engage with it and use it. But it's actually not important how good it looks, so you can just ignore everything I just said. The important thing is how you use it. Now, this is quite exciting, and I haven't seen them here at this show, but Cast Lighting, who make WYSIWYG, they've produced Black Box, which is this software here, and Flight, made by Stage Technologies, have produced this software. And the idea of this is it's like a 3D tracking program. It uses your 3D model to reference one point to another. Now, you may have heard of, in the past, people that have little tags, they walk around and lights will track them, like follow spots. Well, this goes a step further. It can do that, but it understands where a person is in relation to the entire piece of set. So if I'm walking over here and there's a flybar coming in, it will tell the software, stop bringing that flybar in because there's someone standing underneath it. Or you could have a set that's got a revolve on it, and as the revolve moves, the lighting all follows it around. So you just create one point and say, I want it here, and as the set moves, the lights know to follow it around. So it's got a lot of potential there. It also gives you the option of completely changing the way we program our lighting. I know Granda may have started to implement something like this in their desks, where you work on an XYZ coordinate system. So rather than having pan and tilt encoders, you'll have an XYZ. So you say, I want my beam of light to be 1 metre upstage and 2 metres offstage, rather than saying, let's pan it this way, let's tilt it that way. So we completely change the way we program. You'll give a designer a little thing like this. They'll walk up and say, I want a spot here, I want a spot here, and they're my specials. Now, every light knows where they are, because it understands where it is relative to that spot using the 3D visualizer. So that's the future, and probably in 5-10 years' time, most lighting desks will use something like that, and we won't be thinking in pan and tilt values anymore. We'll be thinking in X, Y, Z. Taking an even bigger leap into the future now. This is effectively a Star Trek holopad. Trust me on this. This is real. Jaguar have invented this. This is the Jaguar Factory, and they've created a box with white walls, and they project with 3D cameras on every side, with some 3D glasses on. And he sees everything on a one-to-one scale around him, the inside of this car. So he's got the steering wheel, the gear stick, the rearview mirror. You can see how it reflects for the windows at the back. So without having to build a full-scale real mock-up, you can sit in the visualization of this thing and experience how your visualization or how your end result's going to work. Now imagine this in theatre. Just imagine having a room like this and you have 3D walls all the way around the outside, and you can bring your cast in and you just build your set in 3D. You give them all 3D glasses and they can walk around a virtual set. Your lighting design and production team can be sitting there visualising the lighting in 3D over the top, and at the end of the rehearsal you press a button, you load the next show, and another company comes in and they do their rehearsal. It's really far into the future, and if someone wants to invest in it right now, I'm happy to take it on, but it's a potential for the future. We could see where this is going to go. But before we have any of this good stuff, there's a little problem, and I'd like to bang my drum on this one. I have a lot of problems with Ethernet protocols, because it seems like every manufacturer is just producing them left, right and centre at the moment, and they guard them jealously. They won't standardise, and they will keep their own protocols to themselves and won't share them with others. And at the very least, I'm trying to get Stage Technologies system to talk to my visualizer. Even that's quite a basic system that's finding quite hard. So I'm using this opportunity while I've got a voice and there's a few people listening to me. I hope you are anyway. I want to just say to the industry bodies out there, ABTT, USIT, whoever, let's try to standardise all this, because when DMX came out, USIT said, right, this is going to be DMX 512, and from now on, that's what we're going to use. And suddenly there was a flurry of moving lights, lighting consoles that could all interact with each other. And at the moment, we've got a situation where there's only a few protocols that will actually talk to most lights, and you've still got to convert them somewhere, or you might have to go through something else. And it's not a good thing for the industry. It's not moving us forward. It's stigmatising us. We need to standardise this before we can move forwards. Now, that's sort of the end of my paper, and I hope it's given you something to think about. Your next idea might actually work, because you now know that you can use visualisation. I hope you agree that it's very exciting. I mean, I find it very exciting, and it's a wonderful job to have, to work with this system, and a wonderful place like the Royal Opera House. And if any of you want to ask me questions about it, I'm going to give you my email address. You can contact me. So it's not a new software. It's not. It's very old, but it's new to our industry. It's new to theatre. And if you didn't see that it's a good thing for us before this presentation, I really hope that you see it now. So thank you very much for listening. And if anyone wants to email me or listen to my Twitter feed when I occasionally remember to update, feel free to follow. Are there any questions? If not, you can come and find me later outside. Yeah?
So after this visualisation process,
Yeah.
I'm trying to get the words out, do you ever get frustrated personally when you see, because you'll think actually what the designers put together is not how you envisioned it either? Does that make sense?
Do you mean in terms of the way it transfers back to the stage?
Yeah.
That is very frustrating. Right. I don't find that I have a low expectation of what's happening. I have a very good understanding of how it would transfer to the stage. Yeah. So I'm not disappointed. But I'm disappointed when I see that the designer's disappointed. When they go, oh, I've done all that work, was it really worth it? And I try to explain to them that they still saved so much time, it was still so beneficial to them. But they just see the fact they've got to go and do some work, and they've got it in their heads that then you've got to do it once and it's over. So it can be quite frustrating. We don't make mistakes, sometimes the lights are hung back to front. It's very hard to tell which way round the lights are hung in the model. And I spent a lot of time, and that happened on the Olivier's, all the Mac 3s were hung, 30 Mac 3s were hung back to front. But you just do a pan invert and it's back the right way, or you spin them around. So, there's ways to fix it. But what does frustrate me is when people don't understand that it's not a perfect system. It's a tool to help you move forwards, Any other questions? Anyone experience of visualizations they want to share? Has anyone used it? Be interested to hear anyone that's used visualizations to success or not. No? Yeah?
When I was at school, I managed to acquire a version of WYSIWYG that I borrowed from friends. And we sort of mapped out the school hall and stuff, and that actually worked quite well.
And did you find that what you produced came back accurately?
Yeah, no, it wasn't too bad, because we were only using a couple of generic fixtures, so it did work quite well.
So it gave you an idea. So you didn't use any moving lights? No. Yeah.
Scope for it to go wrong, but it was really useful, saved a lot of time.
Yeah. Good. Has anyone else used it to success? Yeah?
Kind of interested in, it looks as if you've only had one opportunity to move the concept from Royal Opera House to the O2.
Yeah.
And how you feel that you work on like a touring basis.
Okay.
Where you're doing different venues and you're incorporating TV and video, different PA systems, different lighting systems, and how it could be almost done in the bus before the next gig. Yeah. That type of thing.
Okay, well, we have taken it to some other venues. When we've been on tour, we took one of our operas to Japan, and we recreated the lighting rig. And it was a very quick process, because we already had the 3D model of the set. That's actually the hard bit, is building the 3D model for that. The lighting rig actually is quite quick to make if you've got a plan. And especially if the venue's going to recreate your lighting rig, if it's a tour where you're laying out your own trusses and hanging your own grid, it's going to be almost exactly the same. You might just need to move things around. The idea of putting in the bus is quite interesting because of the amount of computer power you might want to have. I don't know if the bus's batteries will run it, but if you had enough, and if it was a small enough model and you had a big enough laptop, you could probably do it. And then the other problem you'd have is expertise. You'd have to have someone that understands the system that can work with it. If that person's your board op, they might be pretty tired after a gig, and last thing they want to do on the night over, they've got they want to drink beer. They don't want to be sitting there updating the new model. But it's perfectly feasible, and PRG have a facility just like this. I think we're the only two people that have someone dedicated to run this in the country. There's only a few of us in the world that do this as an occupation. But PRG do a lot of projects outside of they do everything, the Millennium Wheel, fireworks, and New Year's Eve, and big gigs. I think they're doing the Olympics as well. So they have a lot of experience sort of moving to other venues. And providing you've got the information, providing you've got plans, you've got models, you've got some pictures, always helps. You can actually create it accurately and get some textures on it. You can create virtually anything, and you can do it quite quickly as well. Yeah.
It was tried. We tried it some years ago in television. Trying to do some of the major, very big shows like Miss World. And using a German program called Virtual Studio. I don't know if you've ever
I haven't heard that one, no.
Very, very old.
Yeah.
15, 16 years ago, probably even longer. And the biggest problem we had was various people bringing, similar to your protocol problem, was bringing Vectorworks in with
Yeah.
AutoCAD,
Yeah.
and now it's probably compounded with SketchUp, you know. So
Yeah.
not only that, the venues that we were using, the plans could be up to probably about a foot and a half out.
Yeah.
Because the architectural plans were never as accurate as they could really be.
Yeah.
And it kind of nipped it in the bud, I think.
Yeah, because you were hoping for it to be much better
Yeah.
than it was.
Yeah.
Yeah.
It eventually, it didn't really highlight the clashes of set, lighting, camera positions. It just became a mismatch and became more effort to actually sort it out
Afterwards.
where everything
Yeah.
kind of, obviously it's moved on a bit since then.
Well, that's kind of the point of this presentation, is that there's a lot of people that have had your experience, even as early as 5 years ago, and they go, oh, visualisation, it's not worth the effort. And it's like, well, actually, with the right tools, the right technical abilities, everyone should be able to use it successfully. And that's kind of what I'm trying to highlight. And there's a lot of other examples of it happening outside the industry at the moment. And for instance, the Olivier's, when they came in, we had external programmers and designers. I said to them, have you used a lot of visualizer before? Oh yeah, every day I own a copy of WYSIWYG, I do it for everything. You know, it's starting to become a bit more accepted that you work with it straight away. So it's sad to see here you had an issue like that, but 15 years ago, I mean, it's changed a lot since then. So yeah, you probably find a new system. But the thing that let you down there was actually the information you were given.
And computing power, something which you've
Yeah, yeah,
which you've highlighted, it took quite a bit of power to make the system work.
yeah,
But it was useful in certain respects, as that you could, even in pre-production planning, you could figure out where sight lines was the one you mentioned, and
Yeah.
camera positions, which is the
yeah,
biggest bugbear for health and safety people, getting them in the right position. So it did kind of work, and I could see the potential of it. But I think the TV people and various other people decided that it wasn't really worth investing any time, no more time.
yeah. Especially it can work out quite expensive.
Yeah,
But-
it was very expensive.
Yeah.
It's only the largest shows that I've ever used it on.
Yeah. Well, I think it's become a bit more mainstream now. Hire companies mostly have a copy. So it's, I mean, you don't go necessarily go off and buy yourself Mac 3s, but you can hire them. It's going to be the same thing. In the future, I hope that there'll be a visualizer on call. You can just find out, can I have my visualizer, please? They'll come along with all the computing power and on the software. What do you pay for? And you're just paying for the service. So it become a bit more accessible then to companies that with smaller budgets, or they don't have the ability of the Opera House to have a full-time system like this. And we use it. We need a full-time system, but smaller companies, like for instance, the National Theatre bought into the system, and they pull it out when they need it, but they don't have the technical expertise to pick it up and run with it as well as we do, because they don't work with it every day. So it's almost the sort of thing where you want to have somebody, like a freelancer, that come in and just take it on for you. And 5 years' time, it could be a lot of that. There's going to be it's going to be a big industry for it, I think. Any other questions or discussion points? No? Great. Okay. Well, that's sort of round up a good sort of time anyway. So thank you very much for listening. I hope to see you around.